Okay, today we're going to talk about evaluating and simplifying some algebraic and numeric expressions using substitution and the order of operations. We'll take a look at some vocabulary to get us started. A variable is going to be a letter used to represent one or more numbers. It's the unknown in your, let's say, equation or expression. So I'm going to give you an example of an expression up here. I'm going to say 2x minus 7, where x is the unknown. We don't know what that value is. It's a variable. Next, we have a numeric expression. That's root word, maybe number. So we're talking about an expression that just has numbers in it. An expression is a mathematical phrase involving numbers and one or more operations. So if I had 2 minus 7, this would be a numeric expression. Notice there are no equal signs. It's just a phrase. It's not a complete sentence. So we just have numbers here, and we have one operation of subtraction. We also have algebraic expressions. Our root word there would be algebra. These are also called variable expressions. So just like a numeric expression, it's a mathematical phrase that involves one or more operations, but it also involves at least one variable. So if we go back to our variable example, that is an example of an algebraic expression, but let's write out another one. Let's say we have 14, I'm going to use a different variable. I'm going to say y here, divided by 2, and then over here, plus 5. This is an algebraic expression where I have a variable and I also have at least one operation. Here I have 2. I have division. Actually, I have 3. I have division, I have addition, and I also have multiplication in between that 14 and the y. Let's take a look at some more vocabulary. In here we have some powers. I'm going to make that a little bit bigger. A power is an expression that represents repeated multiplication of the same factor. And a power is composed of both a base and an exponent. So let's take a look at our example here. The power is this, 2 to the 4th. The power represents the base and the exponent. The exponent in this case is the cute little 4 hanging up at the top. And the base is the bigger number, so that's 2. Bigger as in size, the larger number. It's the root, the base. When we have a power, that means we are repeating multiplication over and over and over again. And what we're doing is we're taking the base number, 2, and we're then expanding it out with multiplication 4 times. The exponent tells you how many times you have to repeat that multiplication. So we have to repeat 2 times 4 times. So 2 times 2 times 2 times 2. So I've written that 2 out 4 different times with multiplication symbols in between. That's my repeated multiplication. It's important to know that we're not saying it's 2 times 4. 2 times 4 would be 8, where in this case, 2 to the 4th power is 2 times 2 times 2 and 2 again, which gives you 16. You can verbally say the power as 2 to the 4th power, or you might say 2 to the power of 4. We'll take a look at how we might say and write some of these. So it says, go ahead and write the power in words and as products, then find the numeric value if possible. So 8 to the 3rd is how you would say that. And you might write it as 8 times 8 times 8. And then I would have to go ahead and do that math. 8 times 8 is 64, and times 8 again. Okay, so that's how we find the numeric value. If possible, we would find that numeric value only if we just had a known base and known exponent. So I'm going to go ahead and clear what I wrote there so we can take a look at it fully expressed for all of these. So we've got 8 to the 3rd. Another way you could say this is 8 cubed You could also say 8 to the third power or 8 to the power of 3. Written out in multiplication form, it's 8 times 8 times 8, which value is 512. For letter B, 4 to the 8th power, 4 times 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 4. We wrote it out 8 different times. We can evaluate this, and it comes out to 65,536. For letter C, this is 1/3 to the power of 4, or 1/3 to the 4th power. And we would write that as 1/3 times 1/3 times 1/3 times 1/3. And I'm going to rewrite it a little bit differently. I'm going to write it just side by side like this. And just to review working with fractions, when we multiply fractions, we multiply straight across the numerator, so straight across the top. 1 times 1 times 1 times 1 is 1. And then I'm going to multiply straight across the bottom. 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 again gives you 81. You might also see, and we're going to work with exponents later on in a unit in the future, you'll see that when you have a base, like a fraction, raised to a power, you can also write it out this way. You're distributing the power to both the top and the bottom, like that. So that would be 1 to the power of 4, which is 1, and 3 to the power of 4, which we've already evaluated to be 81. So that's how you could do it also. Our last one is a variable expression. It's a variable power. I have x to the second power. So this could be x to the second power, x to the power of 2, or x squared. And we can only write this out in case of multiplication. So we're going to take our base and write it twice, x times x. And we can't evaluate this because we don't know the value of x. It is unknown to us.